All right. Today is part two of this thing. First, we spend some time go through the some basics. You guys all spend time doing math, right? We start from the very beginning. The first idea is set. You guys know what a set mean?
Yeah.
You do. What is a set?
It's like when you're trying to separate a group of numbers from the rest of numbers.
Okay. Okay. You don't know set at all, right?
I forgot.
Okay. That's okay. A set is well, let's say in schools, right? Teachers is you consider a set. Student a set, right? Boys a set, girls a set, integers a set, right? Real numbers a set. Set doesn't have a finite number of elements in it. But for instance, we do a set. We call this set A, right? We call this set is x is between 0 and 1. You know what that set means?
Yeah.
What does that mean? Do you know what was A?
Everything from 0 to 1, just not 0 to 1.
Right. You get it? The A is any number. I mean, real number, whatever. Yeah? That makes sense? Well, you know, now we just sort of set up the you know everything that we were talking about. We just talk about it in a different setup. Why we do this, you see it immediately. Okay, let's say let's call a B, right? Let's say from 0.5 to 0.6. Right? That makes sense? That doesn't include 0.5 and 0.6, right? If you do this, that includes the 0.5 and 0.6. Right? Oh yeah. Okay. So now we can now you have two sets. Yeah, two sets. There are relations between them, right?
Yeah.
Now what we call this. This is A. Actually, B is a subset of A. It's like you have a chapter of the book, right? Then you have subchapters of the book. Each subchapter is a part of the big chapter. It's A is a chapter, the set. B is a subset of A. And then, I don't know how to remember this, but anyway, B is kind of smaller side. The A is the bigger set.
To say act is like, just A is an act and B is the scene.
Yeah. Okay. Yeah. Right. Actually, I don't. I you know, me personally, I don't remember the subset. Though I don't really. You know, I prepare for this talk, this thing, right? So I know it's called a subset, but really, before I prepare, I don't know. But I know you write this, I know B is part of A. B is contained in A. I know that. Just the symbol in math, I think symbol speaks more than the word. Then once you get used to the symbol, because when you write things, you never really have to tell people anything. Then you just forget. And then there are two things. We have A. Let's call this is A. Let's call this is A, right? Then they call this B is part of A, right? Then let's do C here, right? C goes beyond A. Let's see, whatever. Just on principle. You want an example of this? Or we can just do this. C is let's just say C is say 0 to 1, right? Let's say
0.5 to 2.
0.5 to 2, right? That's C. There's some intersections. There are some, you understand this? The part of C doesn't belong to A. The part of it doesn't work in this condition, right? Okay, now let's look at this. Let's do this first. Okay, you know what this is?
Yeah.
Okay, do you know? Okay, what is it?
It's like called a union.
Okay, wow, you actually know that. Huh? Let's write this way just to make the symbols clean. What is the union?
It
A and B.
means it's both of them.
Yeah, this whole area. You get it? How do you remember this?
I just remember it.
This is like a ball you put them all in.
I just remember doing it in algebra.
Okay, how about this? How do you remember this? How do you remember this?
It's like an intersection. So for like both of these, it would just be this middle part.
Right, this part. This is the intersection part. Right? This is shaded part. This is the intersection part. Yeah? Does that make sense?
No.
Okay.
First one
A
isn't that the
AB
intersection
union
part?
is this whole area. This whole area.
Uh-huh.
Then I don't know how you
What about the ones before that? The first one is the intersection.
this is the intersection. This is A. Everything that's A or B. You're in A or B. You're either in A or B. Then you're okay. You're in it. I think I heard somebody. I don't remember this way. I think somebody say this is a cup or a bowl or something. You just put A and B into it. But this is something you won't be able to put in. So this is smaller. This is just both A and B. This thing you had to be in both A and B. In other words, if okay, we're getting this a little bit screwed up. But anyway, let's just call this B, right? Forget about this. You have to be between 0.5 and 1 to be both in A and B. Right? That's the intersection. Yeah. Very nice. Does it make sense?
No.
So
Which part? Which part
The
of it?
first two.
so like subset.
These two subsets, right?
Yeah.
Okay.
So subset is like if this is A and this is B. If B is a subset of A, it'll only be this part. If A is a subset from B, it'll be everything in if it's everything of A except for B. So it's like so this one is like A except B, and then this
Okay,
is
yeah,
B
sure.
except A.
It's like A is greater than B, kind of thing. But it's not. It says A is greater than B. Then B is totally inside A. Every part of B is part of A.
Okay.
That's so correct, because then this is B less than A, and that's the same.
Yeah. This is actually the way I remembered it. I don't know how I remember this one or this one, but and then there's a set difference of. Then you're talking about how do we do this part, the A that's not part of this, just this part, right? Not part of this. And there's a way of saying it. That's A. It's a set difference. So they also complement. This is not really used that much, so you don't have to worry about it that much. And then there is another thing you don't have to worry about that much. It's Cartesian product. That's the A cross B. This is. Have you ever heard of this?
No.
Okay, let's say you have an X, right? You have an X, and then you have a Y. Let's say, it doesn't matter what X is. X, you know this kind of.
Yeah. X is the element of all real numbers.
Yeah, let's say X, Y is also an element of a real number, right? So X is a set. In other words, X is part of an A that the X is from minus infinity to plus infinity. Do you know what I'm saying? X is a real number. Y is a real number. You know? Now you have This is x, this is the y, right? You have a point somewhere. You know? This point is determined by its x coordinates and y coordinates. Yeah? Now, you actually, the way you said it is a, the Cartesian product A and B equals to, you actually write it this way, A, B, just like a coordinates, right? Then A is part of, A is an element of a big A, and B is a part of big B. Don't worry about this kind of writing, okay? Just you understand this thing and this thing exist. The Cartesian product, this is called these kind of coordinates, called a Cartesian coordinate. It's you have a point that has x and y, right? X is a set, y is a set. How do you call this kind of relationship? It's called a Cartesian product of x and y. It's two sets. I'm just gonna have one element of set A and then another element of set B, and we call this, and this becomes something. In this example, it becomes a dot on the plane, on this plane. You know, how do you call this set? From actually the relation of this set and the set A, and I mean, yeah, you can call set A and set B, right? We call this a Cartesian product. That makes sense? It's just a way of calling it. In mathematics, you call things, and then we're not going to do anything with this. Probably we won't do anything with this too, but we're going to do something about this. And see how, just to show you how these symbols go along. How we use the symbols. That makes sense? That's okay? Yeah. Oh, by the way, let's just say something because we're going to put this on the internet. For those people that got problem with this, the first time you do this, you want to understand just from one small logic to another small logic to another small logic. Do this slowly, and if you don't get it, this is a video. We can go back and play it again. You don't want to, at least when you run through this the first time, don't try to get the big picture that we're actually trying to present here. We're not presenting a mathematics class. Mathematics class is kind of swimming. You actually have to get in the water and swim. That's the exercise. If you just know all the theories of playing tennis, I give you a racket, you won't be able to hit any balls, at least any balls with any velocity. But anyway, just do this again and again. The first time, just make sure you get the small logic we're presenting from one point to another. If that's okay, then you move. Okay, we'll move on. Now, your question?
No,
okay.
I'm good.
We move on. Now, more of the stuff. Okay, you know what that means?
Nope.
Okay, if you don't know, that's okay. Let's do both of them. Actually, let's do this and make it easier. This one I do know how to remember this thing.
Like, I remember this part, but I don't know what these two are.
This is the mathematicians screw around with things. This actually is A. This is E. You understand? It's flipped in a certain way. E, you cannot flip that way, right? Upside down, this is still an E, right? So they didn't flip E that way. This is for all the X in this whatever. This is for, there exists one X in this. Just a way of writing. When you for instance, there exists in this, right? When x equal to 0.5. Yeah?
So like when it's the E, it's just only like one thing in like zeros.
At
or
least,
something equal
yeah,
to
it could
X,
be
like,
exist
yeah.
too. X could be say x is an element of a set from 0.2 to
I
0.3.
think you should graph it because the brackets. No, I don't think Abby knows what bracket is.
Oh, you know these brackets difference? The difference between this and this. That's what you're saying?
Yeah. So like
You know difference
Yeah,
between
I know what it is.
this
Yeah,
includes
X can be equal to that thing too.
right. This you cannot right. It doesn't include 0 and 1, but includes everything in between. Good.
I don't. Here, just for the hell of it.
Yeah. This is written. I don't know. I'm throwing something in here. Just throw something in here because maybe you'll see it, but I'm not gonna use it. Maybe I'll use it anyway, but it doesn't matter. Okay. Now, let's just say there. We deal with we're done with this. Okay. Now let's look at logics. Mathematics has is a really we're processing logic from. That's okay. Yeah, we'll just leave it on. Let's say you want a new paper.
Sure. If we're doing something new, then
Okay. Yeah. Do a new sheet of paper. Now, let's start with an example. Probably is easier. Let's say John is a king. Just say is a king. Okay, is a king, whatever. Yeah. Some English people they use these names, Edward or whatever, as king, right? And then there's another thing. John is male. Huh? They're both correct, right? But both factual.
yeah.
If you know John is the king, do you know John is male?
Yeah.
Sure, right? If you know John is male, do you know John is the king?
No.
Not necessarily, right? So we say from this you can go to that, but it cannot come back, right?
Oh, it's this 1 to 1.
Let's say this is all the males, right? These are the kings. Right? King is a subset, kind of small subset, but doesn't matter. It's a subset. It's plural. There are other kings, right? It goes. It goes in this direction.
Yeah.
Yeah. So, have you ever heard of sufficient and necessary conditions? Which one? How does it go? Which is sufficient for which?
Like, I don't know which one is which. But
Just to make a guess. Just the word. I mean, you know, sufficient, necessary. These are two conclusions, right? Two whatever, two facts, two elements. Is it from which element is sufficient for the other elements? How would you go?
So like this is sufficient to know this,
Yeah.
and this is necessary to know
For
this.
Yeah. Do you get what I'm saying? You get what you're saying?
Nope.
Okay. Let's say x is an integer, right? X is an integer or whatever. Okay, the integer, right? X is a real number, right?
Wait, that's integer.
Yeah, well, for you go. If it's a positive integer, you can use natural number, whatever. That's some. I think that's German. You know, the rational number is a Q, right? You ever seen it? No? Okay, never mind. We'll get to that. Integers are not high. Just, I think some German come up with this. If x is an integer, you know x is a real number. but x is a real number, it cannot get to x is an integer.
Yeah.
Okay. So we call this A is sufficient for B. This is sufficient for this. You have enough. Sufficient means enough, right? This you got enough. Enough for this. This is not enough for this. But this is necessary for this. In other words, you say, John is a king, right? Then he's necessarily a male.
Yeah.
It's it's just two words used to describe this kind of a thing. A goes to B, right? You call A sufficient for B. It has some meaning with in the word, but it's not really exactly. Word is a word. I mean, could mean all kind of things. But this is very precise. From one set, you get to the other set. You see, when you know it's in set A, right? You know this thing in set B. You know there's an element, John, right? The John is in the king set. Then you know John is part of the male set. Yeah? That makes sense? Okay. So this is the sufficient and this is necessary. Okay, now let's do this thing, right? So A is sufficient to get to B. Yeah. The question is, from this, can you draw this? Is this true? If this is true, do you know if this is true?
Not necessarily.
Okay. Well, let's not make it, because necessary here mean a real number. No, it doesn't. I don't know. Let's think about it. No, probably not. Because necessary will have a meaning here. Not necessarily. Maybe exactly right. Yeah, not necessarily. Because necessary is this relation,
Yeah.
right? Yeah, actually, you said exactly right. Not necessary, right? Not necessarily. Anyway, let's not screw this one. A is sufficient for B, right? B is definitely not sufficient. We saw that, right? Right? An element in here is not in here, right? So you cannot say element in B that is an element in A. Yeah. In this case, we're saying this is the A, this is the B, right? This element in A definitely an element in B, so A can go to B, right? But B cannot go to A, right? If you're not in B, can you get to the conclusion if you're not in A? This one is wrong, right? However, if you know you're not in B, can you get to the condition that you're not in A?
Yeah, because if you're not a male, then you're not king.
Right. Do you get my point? Okay. You know, if you're in A, you're in B.
Yeah.
Right? Of course, right? But, okay, let me do this. This is everybody, right? This is everybody, right? This is A. This is the B. Then this is A, right?
Yeah.
Not B means this. You're not in B. Not B means this shaded area.
Okay.
Yeah? This is not B. This is B, then this is not B, right? If you know this is not B, this guy is in here, can you say this guy is not in A?
Yeah.
Obviously, right? Okay. Let me say I want you to prove if you have an A, you get to B. You can't prove it.
Yeah.
You can't figure out how to prove it. However, you can prove if it's not B, then it's not A. You can prove this one.
You said it backwards. You said A to B.
Okay, let me say it again. Okay. If A, prove B.
Yeah.
Right? We're going to see a lot of them. Well, once we start going around this stuff, you're going to see a lot of them. I'm not going to get an example here. It's just too convoluted. Let's just say, if you know John is a king, then John is male. Okay?
Yeah.
Let's say they want you to prove it. That's actually whatever. Okay, just take it. Take that as I want you to prove John is a king, then John is male. Okay, you don't know how to prove it. However, you can prove if John is not a male, then John is a female, then John is not a king. You can prove that.
Yeah.
Well, you
Right.
just proved it by saying that because
Yeah, kinda.
Yeah.
That if you prove that, right,
Yeah.
you prove the first statement. If John is a king, John is male. Okay, this is always true. In other words, if you get a problem, right,
Yeah.
they want you to prove something. You don't know how to prove it, but you can prove if not B, then not A, right? You prove it. You start from the conclusion. You say the conclusion is not true. Then you go back to it. There are a million examples for this because this makes the proof so much easier. But anyway, let's see. Okay, there is another thing. Necessary and sufficient. If necessary and sufficient is a condition that A goes to B, A is sufficient for B, right? Then also A is necessary for B. That's this. A is necessary. I mean, A is sufficient for B. That you can go that way. A is also necessary for B. Then actually it goes this way. This is called necessary and sufficient. Okay. It's written as A. You know why that?
If and only if.
Yeah. You're cheating. Okay, you're reading my notes, but anyway. Okay. There are all kind of examples. For instance, an equilateral triangle, right? This is all the inner angles. They're 60 degrees, right? That's, if a triangle with all the angles was 60 degrees, you can go this way, and if the other way. That's equilateral triangle. Is a triangle with all these sides at the equal length, and this is 60 degrees, 60 degrees, 60 degrees. You know one, you know the other. Yeah, it's got if and only if. Okay, we're gonna rest a little bit.